Okay, so this is our final 3D map painting. So I've rendered this out of 3D Studio Max using camera mapping techniques and a large 2K map painting that I've created in Photoshop. Through the next series of lectures, you'll see how a complex shot like this can be created with relatively low numbers of polygons and very quick render times. So let's get on to the creation of the shot and hope you enjoy this. Okay, so let's start the process of creating a camera map projection. In other words, camera mapping the shot. I'm going to start creating a bunch of models here in the relative placement of rock cliffs, mountains, and the waterfalls surrounding this low poly palace that I've used to create the concept art. And I'm going to use them along with the camera to create an animatic. The goal of the animatic is going to be to create a rough animation that we can get approval from the visual effects supervisor and especially the director. And in hopes of getting early approval, we can then continue on our way down to completing the final shot with this camera path, this camera animation in mind. A good way to start the process is to use the concept art as a projection map. Concept art is a good stand-in for your final map painting, and in many cases you won't have started on the final map painting at this point in time. It's really good to get the director to approve a camera move, because as you'll see later on when you're camera mapping a shot, if you can possibly have the camera animation path finalized, can really save you time in the end. So in 3D Studio Max, I've loaded in my my sketch in the background, so I can constantly refer to it through my camera. It's just loaded in as a 2D background element. Right now, it's not on any geometry. We have the 3D palace. You can see it's lined up. I have a camera positioned that gives us a similar perspective to what I want in the end. And I'm going to start placing some cubes. These cubes are going to be just some type of geometry, simple geometry, that are going to be the rough position of the rock cliffs. So far here we have rock cliffs on the left-hand side, a couple cubes duplicated. Just try and get them in the proximity of where you feel the cliffs are in relationship to the camera. Now, if your placement of these objects isn't quite accurate, it's okay for now because we can always change it a little bit later on. Right now, the goal is to get some layout. We'll quickly texture map all of these low poly objects, and then we'll animate camera really quickly over top just to see what we see. We tend to do a lot of that with camera mapping. Camera mapping is really one of the ultimate ways of cheating to create a 3D animation of your map painting. So one of the ways to most efficiently cheat is to let the computer do a lot of work and create minimally what you need to create, and then see what you see through the CG camera. After you look through the CG camera, after you do a few animatic renderings, it becomes quite obvious as to the scope of work that will be involved in creating the final shot and how much extra painting you'll have to do aside from just the 2D painting, if any. So I just modeled a quick little lollipop tree, and this is going to give me scale. It'll give me some scale in our 3D world. It's a tree that I can place close to the palace and then drag it over near the camera on one of these cubes that are acting as a rock cliff. This helps me to determine what scale I think these rock cliffs are going to be here in the foreground, and it'll give me a good indication of whether or not they're far enough away from the palace and close enough to the camera to give us a good sense of scale. I'm not going to have 3D trees in this model in the end, but this sense of scale is important because once these texture maps are projected onto this geometry, they are going to have a relative movement as the camera moves. We're going to have parallax, so we're going to have a sense of relativity between foreground, background, and midground objects. So we're going to try and get these trees to read correctly scale-wise. Right now I think it's pretty close. The closest tree looks like about the size of the tree in the concept art, and then the farthest tree looks like it could be acceptable next to the palace. I'm just going to start laying out some geometry for that little wall where the waterfalls are falling. The top of this cube will also act as the top of the lake. Typically when I want to deform some of my objects to line them up, I either change them into an editable poly or I put an edit mesh modifier on them, and just drag the vertices around the scene so that they roughly line up better with the painting than they used to as a cube. In the end, what we want is some full coverage. We want the geometry to cover the entire scene. We need the geometry to cover the entire scene simply so that when the camera map is projected onto the geometry and then the camera is animated around the scene, we have every pixel from the painting landing on geometry. If there's a spot where we see through geometry to empty space, then of course we're going to have a hole in the painting. Because the scene is modeled with a pretty low poly count, it's a quick render. Camera maps are notoriously quick renders. Another factor that comes into play with the quick render times is when we create the texture maps for these scenes. Since all the lighting is painted in and all the shadows are painted as well, there's really not any lighting and shadow calculations for the computer to do. What we're doing is we're giving the camera map, our texture maps, we're giving the map painting a self-illumination in Max. I believe it's called an incandescence map in other programs. But what it is it's essentially a map that is not prone to any lighting or shadows. It can't catch any shadows because it's brighter than another object that would have that ability. So in the midground to background, it's very easy to start using simple cards or planes to catch your painting. So I'm just going to line up this plane with that hill on the right. I'm going to duplicate it back and line it up, line another card up with the distant hills and mountains. We want to just scale it up large enough so that it catches all those pixels that we're concentrating on. So at this point in time, the mountain there on the left in the background is closer than the farthest mountain visible to the right behind that tree. So I set up the cards accordingly. I want to have a little bit of parallax in between that big dominant mountain near the center of the shot and the sky. So I continue duplicating these cards back in space. Ultimately, the rearmost card is going to be scaled up large enough to encompass the entire sky. Usually, just to be safe, I try and scale it up just large enough to fill the entire frame. And we'll want to fill the entire frame plus some, because we know we're going to move the camera around. So we're going to see more than just this framing here. So in general, probably 10 to 20% larger for a typical camera mapping shot. But certainly, camera mapping has its abilities to create camera moves that move all over the place and cover quite a bit of ground. So in this shot, really my goal is to create a subtle helicopter move. Imagine a helicopter here above this little canyon where the waterfalls are. And what I think we're going to do is we're going to try and get it to drift from left to right. It's really only going to fly maybe 50 to 80 feet. But that'll be enough to give the audience a sense that this is a real 3D environment. If a place like this existed in real life nowadays, really, that's the way we would shoot it. So I'm just back in Photoshop. I'm taking another glance at what type of layers I have broken out, where I want separations. With so many layers, it's just good to remind yourself what maps are cut out, what elements are cut out from each other. Certainly at this point in time, you want these elements named. It's important to name them, just because you have to manage all of these elements as they come from Photoshop. They become texture maps. They're going to have their alpha channels that show 3D Studio Max how you want them cut out, and then they have to be brought into 3D Studio Max as a texture map. So one thing I may have not mentioned yet is that each of these layers is saved out. The way I do things is I save them out as a TIFF file, and it'll have its corresponding alpha channel. So let me show you how I prep one of the layers, like this palace layer. So I'll flatten a copy with the palace against an empty layer, save its alpha channel by selecting on it, and then basically I'll use my action. I called my action mult and flat. So what it's going to do is it's going to multiply the data given here so that the edges fatten up beyond the edge of the alpha channel. And then it flattens against black. There is a unpremultiply button that we can toggle on and off in the shader, but it doesn't seem to work with the TIFFs that are created. This is the premultiplied alpha, so we tend to keep it off when I'm using TIFFs in this format. Now I'm going to turn the self-illumination up to 100, and I'm going to change the diffuse color and the ambient color to black. Copy it into the specular color. Here we have the palace, no tiling. This is loaded in our diffuse color. Then we're going to copy the palace texture map over to the opacity channel. Copy, not an instance. And we're going to change just these few settings, alpha image and image alpha and alpha channel. Now we can see the texture map. It's cut out against this colorful checkerboard. This is the basic shader that we're going to use for all of our texture maps. We can copy that shader over and then simply replace the texture map from the palace to the mountains, to the trees, and sky, etc. Just making sure that the differences are between the opacity channel and the diffuse channel. I'm just modifying the camera. Just want to keep track of what cameras are doing here in the scene. So this camera is going to become a camera map camera. Camera map cameras should be set to the appropriate canvas size. So the canvas size is given by our painting. So we'll make sure that in our render dialog here we have the same settings. And then the camera map camera, we'll have to make sure that it does not move. So I've duplicated the shader, and I'm going to replace the texture maps. So now we have, instead of the palace, we have a sky map, and we'll change the way it's being cut out. In this case, since it's the rear map, we don't really need it to be cut out, so we change it to none. This is the only map in the scene really that is not going to require a opacity map. And it's also important to make sure you name all your shaders. Tend to keep the name of the shader consistent with the name of the texture map. Let's see if we can see the texture map on this geometry. We'll turn on this blue and white checkered box and hit F3 to shaded mode. You can see the texture map on the plane, but it's a little stretched. So we apply the camera map modifier and pick the camera, and now it pops into position. So in the frame, now the texture map is applied to that piece of geometry, very much like the background I have with the palace. I'm just toggling it on and off, comparing the lineup. So as we increase the number of polygons in our geometry, the more accurately laid out our paintings and texture maps will end up on that piece. For technical reasons, you don't want to leave it too low. You don't want to leave the polygon count too low, because you'll end up with distortions. Straight lines will fail to be straight lines, and they'll end up wandering and wavering. I'll show you an example of that in a minute. So if you do have any technical problems with your texture maps not falling on your geometry appropriately, make sure you do double check your render settings in the render dialog box, and make sure that setting is the same as your canvas size in Photoshop. Can't stress that enough. If you don't know about that, it can be a hard problem to troubleshoot. So because duplicating the shaders is quite a repetitive task, and swapping out their texture maps, as well as applying all those to the geometry throughout the scene, it's all the same moves over and over again. I'm just going to jump ahead in time and show you what it looks like once we've applied all the texture maps to the geometry. So now all of these objects are camera mapped in the same fashion as I did with the sky and that far mountain. I'm going to turn my attention to the two cliffs on the far left. Left cliff far A is the name of this object, and if we put it in shaded mode, we'll see a little bit of a technical problem here. So you'll see that most of it is black. The texture map isn't appropriately mapped onto the geometry. So sometimes this requires a little bit of troubleshooting. A good place to start is to check that you have the right texture map and the right shader applied to the geometry. Another good thing to do is, if you do have multiple camera maps, in this case we only have one, but if you have multiple ones, you want to make sure that you're using the right camera map to project the position of the painting on the geometry. In some scenes you might have the need for multiple camera maps. What I mean by that is multiple cameras at different points in space that are projecting different paintings. So say for example you have a shot where the helicopter carrying your camera is moving sideways. If it moves far enough sideways, you might have to actually start to see around the corners of things. Maybe the corner of rock cliff or the corner of some buildings. And because you weren't able to see around those corners in your 2D painting, you have to go and create another painting to let the audience see what's around that corner. So back to the polygon problem here. So what we have to do is we have to up the polygon count of this rock cliff. We'll try and get it to display its texture map a little cleaner. This is the issue I was talking about earlier. You see the cliff on the left. As we up the polygon count and we lower it, you can see that it has varying distortions. Here at 1, pop it back up to 3, 4, 6, 7, and basically what we're getting is a nicer, more accurate camera map projection on that cliff on the left there. Vertices in which to push and pull so that you can sculpt these objects so that they a little more accurately represent what's in the painting. Since these are rock cliffs, for example, we will want to go in there and sculpt them a little bit. A good example is going to be the waterfall. Since we can see in the painting that the waterfalls are recessed and then the greenery and the rock protrudes forward, we'll want to kind of get in there and push and pull those vertices to just loosely mimic what we see in the painting. That's the beauty of camera mapping. We don't really have to get in there and detail all of these models. Now, since that cliff in the bottom left-hand corner of the frame is not tall enough, it's not catching the treetops in the texture map, I'm just going to make it a little taller, make it a little wider as well, just so that it does catch everything that we need. You can see the rock texture on the right, and now the cube encompasses all of the trees. And we'll do the same thing for the cliff behind it. You'll notice as we change values in shaded mode, sometimes the screen flickers on and off. That's just the OpenGL shader redrawing itself. So if you have the opacity shader set incorrectly, you'll get a render that shows you the black surrounding your painting. So the cliff on the bottom left-hand corner right now is showing us more of the painting than we want to see. It actually thinks that the black surrounding the rock cliff is part of our painting. So it's just something you can go in, it's something to fix easily. You can just go into your shader and make sure it's set up appropriately with the alpha channel settings that I showed earlier. So now I'm going to turn my attention to the waterfall area. So as I mentioned earlier, you can get into an object and sculpt it. If you choose, you can sculpt at this editable mesh level. But since there's not enough polygons in here and vertices, I'm just going to tessellate it, turn my tension down to 0, which negates distortion. And then if we turn the iterations up to 2, we'll get a higher number of polys. On top of that, I'll add an edit mesh, and now I can go in and control all these vertices. So what I'm doing is I'm looking in the 3D view, and in the areas where there's rocks between the waterfalls, I just select those vertices, get a sense for where they are here in the top view, rotate it around, and then try and pick the vertices that I want to push and pull. So I'm going to select these vertices here where the vegetation is, and I'm just going to lift them up a little bit, just so that they're taller than the surface water of the lake. Since the water is going to lay down flat on top of this entire piece of geometry, pulling these little chunks up here and there is going to give us a little bit of parallax, and maybe give us a little bit of reveal on the water. So I'll slide these vertices over just so that I get a steeper fall off right behind the peaks. I'm just pulling these around in the XY axes, not upwards in the Z axis. It's really just a rudimentary kind of modeling exercise. To build models like these, you really don't need to be an experienced modeler. It's just a matter of understanding some of the basics so that you can get large masses that are represented in your map painting. So we'll do a test render here. Looks okay. Just move on. So I'm going to take a look at this hill here behind the palace. I have a card, and we have that part of the map painting projected on it. And it appears at the very far right side we have a little bit of missing painting at the bottom as well. So we're seeing through to other stuff we don't want to see. So all you really have to do is get back into Photoshop and get into the right layer and add some hillside, add whatever pixels you need to fill out the areas. When you're creating a camera map shot, you'll find that you end up doing a lot of this. You'll end up having to create painting for elements that are behind other parts of your painting. I typically call this underpainting. We're just going to extend this part of the hill. The flawed parts of this hill were hidden behind our foreground tree, and therefore we didn't realize that it needed attention. Working in this manner is good. It's a more efficient way to work. You don't want to start underpainting things from the beginning and making assumptions that you'll need underpainting all over the place. It's really most efficient to complete the concept sketch and project the layers as I've shown, and then take a look around and see what you see. Sometimes we'll even wait a little while until we have a moving camera. At that point in time, the underpainting needs will become a lot more obvious. So same thing with the background mountain here. A little bit of underpainting done. Just get rid of these buildings. We'll just want it to look like the mountain values are coming down. And because this isn't our final map painting, let's just get in there really quick, hide the real distracting pieces that don't make sense, like the crane and these foreground buildings. We'll just make sure that later on, when this is projected for our animatic, that it reads quite cleanly, and there's not going to be any unnecessary questions raised by a director asking what these things are floating back there. You just have mountain tones that'll do the job. To the water geometry here, and we'll since the geometry is ending a little bit too early, it's not leaving the frame on the right hand side, we'll just select So as they leave the frame, they will now catch any bit of the matte painting that exists over there. Okay, so we're just going to take another look at the entire scene with all the items turned on. Just see the status of how things are looking. So there's a big hole on the bottom right hand side. Things are looking a little incomplete. So there's this piece here. It's like a little hillside that comes down and meets the water. And currently we don't really have any geometry in there that represents that. So I'll just get in there and really quickly just zoom in and create a little box and create something for the pixels to land on. So you'll see in a second here, one of the good reasons to sculpt some of these foreground elements, starting with a box, is that there are slightly more polygons and more depth than we have with one of those cards. In the background, the cards suffice simply because there's not a whole lot of parallax with the minimal camera move. But when it comes to these foreground pieces, sometimes it is important to show that not only is there a front side represented by the front side of the cube or a card, but there's a top and the front side rolls up and over just like a hill. So a cube is a good starting point if we want to sculpt a very, very basic hill-like form. So we got the camera map modifier on that box, and we'll pick the camera, and now we'll increase the number of segments in the object. Same steps as we've done before with all the other objects. So we hide everything else and then just do a quick test render of this one object. We can see it isolated and see what we need to do to it. We'll just name the object. We'll try and keep things organized here. And then I'll get into the cube and we'll try and sculpt it a little bit. Give it an edit mesh modifier again and just pull down the corner of the vertices. We don't really want any of that water in the top right hand corner of that cube to be displayed on the cube. So if we just pull these vertices down right to where the hill ends, then we won't see any of the water in the foreground. The water will only be in the distance on the distant object. And keep in mind, this is just very rough, quick and dirty modeling done for animatics. We probably wouldn't be able to get away with such a quick and dirty technique here later on. I just went in there and deleted some faces just so that we wouldn't see them. We don't want any pixels landing on them from the projection. But typically for your final matte painting, you can use forms similar to this, but you'll want to go in and finesse the edges and even get in there and sculpt a little more, depending on what the renders look like. Okay, so let's go in and focus on the region with the palace now. We have the low poly geometry of the palace. And what I'm going to do is I'm going to put a plane in there just behind the palace. This will allow us to hide the geometry of the palace and simply project the painting onto this card. Now if you wish, you could project the palace painting onto the geometry of the palace, And what you'll ultimately get is you get a nice amount of parallax within the members of the palace themselves. But because our camera move at this point in time is probably going to, well, we're going to experiment with the camera move. What we're going to do is we're going to keep the renders pretty quick. For your final map painting, you could determine whether or not you needed the palace to be on more than one card or projected onto the palace model itself for the parallax issues. Projecting the painting onto the palace is going to be the exact same process as I've shown in the past with the rock cliffs and every other part of this environment. So even though, as I said earlier, the renders with camera map projections are quite fast, for animatic purposes, I want my renders to turn around really quite quickly. I don't want to wait a long time to see a 100 frame render. And even if I'm doing several iterations in a day, 15-minute render for 100 frames is a long time. I want to really be able to attack my animation of my camera, find a good solution, and move on to the next step in the process. So at this point in time, hiding all that geometry there in the model of the palace, though it's not too heavy, hiding it is going to make an impact on our render time. So I'm just going to make sure that this card is set up like every other one. Just get in there and pick the camera quickly with the camera map modifier. Do a little test render. Check the alpha channel. It looks like the entire painting is contained on the card. And we unhide everything, test render that. Basically don't have any holes except for the bottom right hand corner. And at this point in time, the tree is going to cover up part of it. So I'm just going to prep the tree to come over to 3D Studio Max as an element to be projected on a card. Now, because it's an animatic, having this projected on a card is completely acceptable, but obviously for your final shot, you'd want to probably get into some 3D geometry or have a real motion picture plate shot for this piece, just so that there was appropriate parallax that matched the animation of the final camera. So let's make an animated camera. I'm just going to change the color of the camera. I want to keep the colors obviously separated because the red camera there, which is our camera map camera, we don't want to move that. Think of it as a movie projector. It's a camera that is projecting the imagery and it's landing on the screens, the movie screen. The movie screen in this case is the geometry. Now if we were to move the movie projector, what we're going to get is we're going to get the movie displayed on a different part of the screen, and we don't want that. So let's keep the red camera map where it is, and the other camera, entitled Camera Animated, this is the one that we can feel free to move around and explore. So as you can see, as I move it to the left, we start to get some parallax in our painting. So a quick test render shows us the transparency. Here in OpenGL we only have the views of the cube edges. And I'm going to change the time length from 1 to 150 frames long, and that'll just give us enough playing room so I can animate this camera. I'll go to frame 150 and choose a position for our camera. And notice what I'm doing is I'm keeping the red camera somewhere in the middle of the path. For a lateral move like this, it makes a lot of sense to have the camera map projecting from the middle of the camera that's animated, the middle of the path. Because we're going to start to see a little bit of pixels smearing across some of the planes. That'll become obvious a little bit later. So what I'm trying to do is design a camera move that is going to move within this limited range around this one red camera. I don't want to have to go and paint a lot more matte paintings to encompass a larger shot. So I want this one matte painting to do the job. So I'm going to keep the camera motion limited. From left to right, there's not a whole lot of smearing. We obviously see that there's a lot of underpainting to do over on the left side, over on the right side. Really, there's parts where the matte painting is just, we're seeing unwanted areas of layers that are really incomplete. I'm just going to go in and delete these keyframes at frame 0. By default they appear and they throw our animation off. And then I'm just going to try and keep this camera move linear as well. What typically happens with real helicopter plates is you have a helicopter that is cruising along at a constant velocity. And the cameraman will take footage from that helicopter, and later on in the editing room that footage will be cut shorter. And because the footage is a shorter cut out of the longer animation or a camera path, you don't really end up with much acceleration or deceleration at the head or the tail of the shot. So that's one of the reasons why I went into the keyframes of the camera and I made all of my moves linear. I just want a nice, smooth, consistent velocity. I don't really want it to accelerate or decelerate at the end or the beginning of the shot. So I'm just continuing to work on the framing of the shot, precisely at the beginning and at the end of the shot. I know that as my camera animation in CG software. There are two types of cameras that are available. There's a free camera and there's a targeted camera. With the free camera, it acts like a camera floating in space, and if you want to rotate it and turn it around, you just rotate it like you would any object. But with the targeted camera, you have the camera, which acts as one point, and you have the long blue line in this case that leads up to the little box at the end, and that's your target. So each of these acts as two different objects at which you can animate separately. So if you want to animate your camera rotating, you can actually grab that target and move it left to right. And I find that I just have a little bit more control that way with these targeted cameras. Okay, so let's call this camera animation good for now. And let's render it out. I'm going to render every 5 frames. So it's quicker, and I'll jump ahead to the final render of it. So what we see here is on the lake top, especially on the left, we notice that there's a lot of smearing going on over there. So the reason for this smearing is, this is what I was talking about earlier. What happens is when you project a matte painting from a camera, if you're projecting on geometry that has polygons that are not perpendicular to the camera, you start to get a little bit of smearing. The less perpendicular those planes are to the camera, the more smearing you'll get. Now there is a way to fix the smearing, but unfortunately it is a little more time consuming. So for the next lecture, what I'm going to do is I'm going to show you how to solve this problem. I'm going to show you the most time efficient way to come up with a nice camera map shot, and that is In this instance, we have one painting that's complete. We're going to pare the animation of the camera back down a little bit, keep it a little closer to the range of that red camera, that camera back camera, and not deviate too far away from where that painting is initially being projected.